Welcome to STech. Today we will study the data sheet of a solar PV module. So we have a data sheet from UTL. There are different parameters written here: electrical, mechanical, temperature, and other details are there. So we will see one by one. First, nominal power at STC P max watt. So this STC means standard test condition, which is irradiance of 1000 watt per meter square, spectrum AM 1.5, and cell temperature of 25 degrees C. So the first parameter shows here 100, 165, 335. This clearly means there are three different panels of 100 watt, 165 watt, and 335 watt each. So we will study the parameters for one panel, and then similarly we can check the other parameters for other panels also. Like we will consider this 100 watt solar panel, and the next parameter is short circuit current ISC. So the short circuit current is normally measured in amperes. So when these two terminals are short circuited, this is the front side of the module and this is the back side. So if we short circuit these two modules, then the current will be flowing as 5.69 ampere at this STC. Okay. Next one is the operating voltage at Pmax VMP units volt. Pmax means maximum power point. Okay. And VMP means voltage at that maximum power point. When the load is taking maximum power, then what is the voltage? So that at this STC, when load will be taking maximum power of 100 watts, so the operating voltage, that is voltage at maximum power point, will be 19.04 volts. Next one is the operating current. Similar to voltage, the operating current at maximum power point is 5.37 ampere. And then the open circuit voltage. At this STC, when these two terminals are open circuited, no load is connected, then the voltage across these two terminals is called as open circuit voltage, and it is 22.61 volts. Then there is the module efficiency. So for 100 watt solar panel, the module efficiency is 14.9%. Similarly, we can see the parameters for other two panels also, 165 watt and 335 watt also. Then there are some common parameters for all the three different ratings. Like the operating temperature of each solar panel is from minus 40 degrees centigrade to plus 80 degrees centigrade. Then there is the maximum system voltage DC of 1000 volt. That means when these solar modules are connected to each other in a series form, then the maximum voltage that the whole series module can withstand is up to 1000 volts. We cannot go beyond 1000 volts. Okay, next one is the power tolerance of plus minus 3%. That means the as solar panels may not be ideal, the parameters may vary. So whatever maximum variations in the output power is from minus 3% to plus 3%. That means for 100 watt solar panels, it varies from 97 watt to 103 watt for different panels. Then there is power. Okay, power tolerance is done. Next is fill factor. So the solar panels have a fill factor of 77%. This is already discussed about standard test conditions. So this completes the electrical characteristics of these three solar modules. Next one is the mechanical characteristics. So cell type. This one is called as a cell. This is the most basic unit of a solar panel. So these solar panels from UTL are made from poly. Poly means polycrystalline materials. Next one is number of bus bar. Number of bus bar is written as 5 dB. That means there are 5 bus bars for in each cell for carrying the current, so that they can pass from one cell to another cell. Next one is the number of cells. For 100 watt solar panels, the maximum number of cells is 36. That is connected in 9:4 fashion. Here currently it's shown as 12 into 6 fashion. 12 cells connected in series, then next one connected in series, next one, next one. Similarly, the whole cells are connected in series in a complete module. So here 36 cells, 9 in one row. Then such 4 columns are connected in series to give overall voltage of this much and current of this much. Then there is the module dimension. For 100 watt solar panel, this is the module dimension. For 100 watt solar panel, this is the weight. Similarly, we have 165 watt configurations also, and 335 watt configurations also. For 335, we can see 72 cells are there. So it is for, maybe we can consider like there are 72 cells, so maybe it can represent 335 watt solar panel. Then there are junction box. So junction box has two diodes. Like here you can see there are two diodes, and for 335 there are three diodes. Then there is the frame. This is the frame of the solar panel. This is the frame of the solar panel. Then there are front glass placed on the solar panel so that these cells can be protected from environmental damage. Then there are cables and connectors. So these cables are there. So the cables can be of minimum 4 mm square, and the voltage rating of the cable should be 1000 volt. And the connectors, these green icons are shown as the connectors. So they can be MC4 connectors. Next, there are the temperature coefficients of these solar panels. So the solar power output depends on the temperature also. So we can see the power output varies as the temperature increases. When the temperature increases by 1 degree C, the power output varies by decreases by 0.43%. That means for 25 degrees C, if it is given 100 watts power, then for 26 degrees C, it will decrease by 0.43 watt. Similarly, for temperature coefficient for voltage, the output voltage of the solar panel will decrease as the temperature rises. Then there is temperature current coefficient for current. That current value increases as the temperature rises. Then these are the basic parameters. So this completes the overall data sheet of the solar panel. So considering about some additional features, so this is the basic unit called as cell. Now these cells are joined in series to form a solar module. Then we will see these solar modules are connected in series to form a string. As we told, we can see this was for 1000 watts maximum, 1000 volts maximum. So these strings when connected, these modules when connected in series to form a string will have a voltage of maximum 1000 volts. Currently there are 6 strings connected in series, so overall voltage is 240 volt, and considering 10 ampere current from each solar panel, so they are connected in series, so overall current will remain same, and the overall system will have a 240 volt and 10 ampere current. And then this starts from cell, then module, then string, and then at last we have the array. Array is a series and parallel combination of these different modules. So we can see these 6 modules are connected in series. These 6 modules are connected in series. Similarly here, and then these all 4 strings are connected in parallel to give 10 ampere from here, 10 ampere from here, so total 20 ampere, 10 ampere from here, so total 30 ampere, and 10 ampere from here, so total 40 ampere. So these will have 240 volts and 40 ampere. Thank you.